Hello, so today we're going to solve this exercise from A-Level Maths code 9709, Cambridge, May-June 2020, paper 41, exercise 5. So we have here something which isn't common in this paper because we have a sort of pendulum, and normally we have inclined planes, we have things that are falling, we have things that are crashing, we have engines, but we don't have this. So the way to think of it is, if it's not an inclined plane, how can I solve it? Well, the best way to do it with the tools that we have in paper 4 A-Level Maths is with energies. Okay, so we know that when P is at its highest position, it has a potential energy, which is M times H, G times H. Okay, so and we know that when it reaches the point that they're asking for in question A, which is when this is it's half, the position is half of its halfway along, so that's 22.5 and degrees, and the other one is 22.5 too, because 22.5 and 22.5, that's 45. Okay, so when it's here, okay, it this one had previously this height, and now it has this height. So basically, so first of all, it had this height, and now it has this. So it's lost this height. Okay, so how can we find that height? Well, obviously, the height that it had at first, we're going to call it H1. We can get it through trigonometry, because we know that as it's the contiguous side, it's 4 times cosine of 45. Okay, and the height that it has now is 4 times the, so we call this H2. So that height is 4 again times the cosine, but now of 22.5. Okay, so that difference in height is so H1 minus H2 or H2 minus H1, doesn't matter. So we find that difference is 4 cosine of 45 minus cosine of 22.5. So if we calculate that, cosine of 45 minus cosine of 22.5, and we're going to multiply it by 4. Okay, so I've done the subtraction the other way around, so it's minus 0.867, okay, approximately. The minus in this case, it means obviously that the second part is higher, but that's what it's lost. Okay, so the potential, the change of potential energy has to be converted when it's moving into kinetic energy, which is half mv squared, and that v is the one that they're asking for. Okay, so that they're find the speed of P when it's at position, let's call it P2. Okay, so if half mv squared has to be a change of potential energy, which is m times g times h. In this case, h is the change of height. So that's 0.8 0.867. Okay, so the mass can be cancelled out, and we have that V is plus minus, although obviously we're going to ignore the minus sign in this case. 10 times 0.867. If we consider 10, that goes there multiplied by 2. Okay, so in the end, V is going to be 10 times 0.867 times 2, and we do the square root of that, and we have more or less 4.16 meters per second if we approximate at 3 significant figures. Okay, so that is the speed that we have at position P2, calculated with the loss. It had a potential energy. It's lost potential energy. The loss of potential energy is due to its to the change of height. So that loss in potential energy is converted to kinetic energy, and that's the way to calculate this speed. Okay, so let's go to the next section. So now the question says that there is a resistance force, and the work done against the resistance force as speed travels is X in joules. Okay, so that's the work against the resistance. The speed at P at its lowest point is, we know the speed at its lowest point, 4 meters per second is its speed, let's say at 0, and find X. Okay, so what's happened here? Now we have a speed at its lowest position. It was here before. The speed here is 4 meters per second. This was P. Okay, and now if we look at the balance of energies, the potential energy that we had at the start is then converted, or the change of potential energy from the start to the end is changed into kinetic energy plus that X, which is the work against friction. So, okay, so we had a potential energy at the start, and then we're going to spend it. Before we only spent it in kinetic energy, but now it's being spent in kinetic energy plus the work it has to do against friction. Okay, so again, if we look at what we had before, so again, what we have is that so we have mg and a change of height, which now isn't going to be the one we had before. Now it's going to be from position P to position 0. Okay, how do we calculate that change of height? Well, now the change of height is going to be 4 cosine of 45, which is the one that we had before, minus 4, because now it's 4 meters. Okay, so that's 4 cosine of 45 minus 1. So we have 4 cosine of 45 minus 1, which if we do it in the calculator is minus 1716 approximately. Okay, so again, that loss with the minus sign. Okay, so that change is going to be half mv squared. We know that what mv plus that x. So x is going to be mg change of height minus half mv squared. So x is m. So I'll do that in the calculator. We were told that m was 35 kilos. So we have m times g, so that's 35 times 10, 350 times 1.1716 minus a half times 35 times v squared, which is 16. So that is 350 times 1.1716 minus 35 times 16 and divided by 2. So that's 130.06 joules. So finally, X equals 130.06 joules, which if we approximately to three significant figures, we get X equals 130 joules. So that will be the answer for that exercise.